Hello everyone, it's Daniel from TechMindFactory and welcome to this next video from the series called Modern Identity powered by Azure. In this video, I would like to talk about passkeys and path to phishing-resistant authentication. Obviously, in this video, I'm going to talk about Microsoft Entra and its relationship with passkeys, but also I would like to explain some concepts. So what's behind passkeys? So we will talk about FIDO2, we will talk about some standards like WebAuthn and CDAP. We will discover more what can we do with such small devices like this. And we will learn more about phishing-resistant authentication. So I hope you will enjoy this video. As always, let's start with some theory. And before we even touch on passkeys, let's start with some standards explanation. Let's start with FIDO. What is it? FIDO stands for Fast Identity Online. FIDO authentication is a global authentication standard based on public key cryptography. It was developed by FIDO Alliance. FIDO authentication is the answer to the big problem. Passwords. The FIDO protocols use standard public key cryptography techniques to provide stronger authentication. So the goal for FIDO is to eliminate passwords and replace them with stronger authentication method. So now let's talk about FIDO2. FIDO2 is an umbrella for identity standards. It's not one thing, one standard. It's an umbrella for identity standards. Obviously, FIDO Alliance is involved here, but also World Wide Web Consortium. So let's talk about FIDO2 and some standards. So let's start with FIDO2. FIDO2 is comprised of the W3C Web Authentication Specification for corresponding client-to-authenticator protocols, or CDAP, from the FIDO Alliance. FIDO2 supports passwordless, second-factor and multi-factor user experiences with embedded, bound authenticators such as biometrics or PINs, or external roaming authenticators such as FIDO security keys, mobile devices and wearables. So the devices I showed you at the beginning of this video, those are basically external authenticators. So those are FIDO security keys. Now the second standard is called WebAuthn from W3C. WebAuthn defines a standard web API that is being built into browsers and platforms to enable support for FIDO authentication. This specification defines an API enabling the creation and use of strong, attested, scoped public key-based credentials by web applications for the purpose of strongly authenticating users. So we have FIDO2 and CDAP protocol, call to authenticator protocol, and we have WebAuthn standard. Yes, so it defines an API, so how to communicate and how to enable this stronger authentication method. So now let's talk more about the client-to-authenticator protocol, so CDAP. So CDAP 2, right now the version 2 is available. CDAP 2 allows the use of external authenticators like FIDO security keys, mobile devices, for authentication on FIDO2 enabled browsers. And operating systems, obviously, over USB, NFC, BLE, for a passwordless or multi-factor authentication experience. So basically everywhere where CDAP 2 is available, like FIDO security keys, and we can use it for authentication. And it's enabled for almost all the browsers. Like if you use Chrome, if you use Edge, this standard is available to you to use stronger authentication. So for instance, to use security keys using USB. So now CDAP defines interaction between user's browser and user's security key, which is basically the credential. So with this protocol, this interaction between the browser where our application operates, the browser and the device is possible. So to summarize, FIDO2 and WebAuthn define an abstraction layer that creates an ecosystem for strongly authenticated credentials. When it comes to FIDO credentials, there are two forms. There is platform authenticator built into the device and operating system that user uses, so it can be the laptop with Windows system installed on it, and Windows Hello can be used for strong authentication. On the other side, there are external security keys. External devices like FIDO security keys, which I showed you at the beginning of this video. Important fact is that authenticators securely create and locally store strong cryptographic keys at the request of clients, under the condition that the user must consent to the operation via the performance of a user's gesture. And we will talk about it more later, but basically every credential is stored on this device. It's not passed to any identity provider, application. All the security keys are stored on the device. And to unlock access to such key, users has to use some gesture, like for instance, put a finger on the device to unlock it and to unlock the key. And we will see how it works later in this video. So this is all together. So there is WebAuthn relying party. So basically this is the application. There is WebAuthn client, and this is basically underneath how WebAuthn and FIDO protocols work together. So there is platform WebAuthn API. So it's built into the browser. As I mentioned, many browsers support now FIDO2 and WebAuthn. So there can be a platform authenticator like Windows Hello, as I mentioned before, but also it can be roaming authenticator like security key, like USB stick that we insert into our computer to unlock credential. And as you can see, the FIDO protocol is used for roaming authenticator. Yes, it's really important to mention, like FIDO or call to authenticator protocol is used with roaming authenticators to enable this strong authentication. So for you, it's very important to just remember that there are basically two forms of authenticators. There is platform authenticator built into the device and operating system, like Windows Hello on your computer. And there is also a second type, roaming authenticator, which can be security key, USB stick that you insert to your computer to unlock credentials. And to communicate basically between those devices, those platform authenticators and relying party, which is application, there is WebAuthn used, WebAuthn API to be more precise. Okay, so now it's time to talk about phishing. So phishing is the most common type of social engineering, the practice of deceiving, pursuing, or manipulating people into sending information or assets to wrong people. Social engineering attacks rely on human error and pressure tactics for success. So now let's put a simple example. This is the email that is potentially sent from the Dropbox. And we can see the information here. You have a new document sent to you via Dropbox due to the large size of the file. Sign in with your email to view document PDF. And there is some number of this document. So basically, when user sees such information, what user will do? User will click this link, user will potentially sign in using username and password, and that's it. Basically, there is leak of credentials, and now the person, the attacker, can use those credentials to access the real Dropbox space of this user and like this person, this attacker, can download all the confidential files from the Dropbox. So we have to be careful, really, what we click, what we open, where we sign in. It's very important, because it's, as you can see, it's just a social engineering technique where there is a fake email prepared and sent to the user, and there is some other link included where user will provide credentials. Okay, what about passwords? Why are they bad? So I put some points here, but I feel like everyone right now understands that password is a bad idea. So passwords are set by the users and can be guessed. It can lead to the situation that the attacker can access all other applications user uses. So as you probably know, many users use the same password to access different resources, like different websites, different portals. So once attacker guessed one password to the one portal, let's say, attacker can use this set of credentials to access all other resources or pages where user has access to. Passwords travel through the internet, so many in the middle can try to steal them and use them. Yes, so it's important to mention that basically, even if we have HTTPS there, still we have to pass credentials through the network. So there is still some risk. An identity provider can be hacked, which can lead to passwords leak. So in a typical world right now, when we have identity provider like Microsoft Entra, like Okta, Auth0, those credentials are stored in the identity provider also. Yes, because we do this check. And even if they are hashed and so on and encrypted, basically there is some risk that still, if somebody will hack identity provider, credentials can leak. So that's why those are some reasons why passwords are bad. So let's talk about phishing-resistant authentication. So if we say that passwords are bad, what is the solution here? Yes, what is the another method we can use to avoid using passwords? So let's talk about phishing-resistant authentication. So I have the diagram here, which presents phishing-resistant authentication with FIDO2, and I would like to explain basically two things: registration process and authentication process. So this first flow you will see is for device registration, and I will show you how to use FIDO security key to basically register the user and enable authentication. Because every time we want to use FIDO security key, we have to go through the registration process first to register the device that we will use in the future for the authentication. So there is a user, there is a browser client, and obviously there is some application, and there is identity provider. This can be Microsoft Entra. And now user wants to authenticate, but user selects to use the FIDO2, so security key basically. So what identity provider will do, identity provider will return WebAuthn request. So this will be returned to the browser, which supports WebAuthn API, as I mentioned before. It can be Chrome or Microsoft Edge. And inside this request, there will be obviously registration request with user identity like UPN. It can be user email, it can be name, and there will be also unique nonce parameter return. And now obviously we have two options here. We can use platform authenticator like Windows Hello, or we can use security key like this USB stick where we have to put our finger to check the fingerprint. In this specific flow, we are going to focus on the security key, and we will focus on the client to authenticator protocol, CTAP. So as you can see, this is the part where CTAP protocol is used, basically. So there is WebAuthn request returned from the identity provider. WebAuthn request is handled by the browser, but then to enable this communication with the security key, client to authenticator protocol is used. So now what will happen? User will be asked to insert the security key into the USB port. That's an example. Yes, so user will put this USB pen into the USB port and will put the finger on the finger scanner. Yeah. So what will happen then? On the device, there will be domain registered like login.microsoft.com. So such small device, this security key, has its own storage, secure storage, where it's keeping the information about all the websites where user, like register the account and would like to authenticate. So in this specific scenario, we are going to talk about login.microsoft.com. Inside this storage on the device, there is also UPN stored for this user, and there is private key and public key stored. Yes, so we have this private key and there is public key also generated for this specific website. And what will happen then, once user completed all the steps, nonce is signed with the private key. So it's very important that nonce that was sent from the identity provider is now signed with the private key stored on this security key on this device, FIDO2 device. So once it's signed, a browser, the client, will return signed nonce and public key that was generated for this specific domain and this specific user. It's very important to mention that private key will never leave this security device. So FIDO2 device. Private key will always be stored on the device. So what we will return to the identity provider is signed nonce and public key. And now what will happen on the identity provider side, there will be nonce check. So there will be signature check with public key done. So identity provider will check whether this specific nonce was signed by the public key that was sent. And there will be nonce value match check. Yes, whether this is the real value of the nonce that was sent by the identity provider during this initial registration process. If the check is done, identity provider will store user UPN along with the public key. So as you can see, only public key is stored on the identity provider side. Private key will stay on the security key device. Perfect. So now let's talk about authentication process. So once we register our device, let's talk about the authentication here. So again, we have user, there is a browser, client, application, and we have browser like Microsoft Edge. There is identity provider like Microsoft Entra ID. User would like to authenticate using the FIDO2 device. So then again, identity provider will return WebAuthn request. So it's login request now, and the nonce is also returned from the identity provider. So this nonce is always returned, and this is unique value generated every time new request is sent. And again, because of the fact that browser supports WebAuthn standard and APIs, and those are like Chrome, Edge, Opera, and other browsers, or Safari, for instance, what basically the browser will do, browser will ask the user to choose the authentication method. And obviously, if user would like to use security key like FIDO2 USB stick, there will be client to authenticator protocol used, and user will be asked to insert the security key again into the USB port and touch on the fingerprint scanner. Once it's done, what will happen, as you remember, on the device we have this information stored. Like we have domain, which is login.microsoft.com. It's taken from the browser using HTTPS, so it's secure communication. There is domain validation done. There is UPN of the user checked. And obviously we have those two values, public key and private key. So what will happen then, nonce is signed with the private key once again. So again, we are using private key that is purely stored on the device, nowhere else. And once the nonce is signed, we return this signed nonce to the identity provider. What is happening on the identity provider side? The signature check is done with the public key, nonce value is verified, yes. And if everything is okay with this nonce and nonce value is signed with the public key of this specific user, we are successfully authenticated. So now let's talk how it prevents the attack. I mean, how FIDO2 can basically prevent the attack and why it's phishing resistant authentication. So I have another diagram here, and there is user, there is browser, client, again, some application running in the Microsoft Edge, let's say. There is identity provider, so Entra ID. And again, we would like to log in, yes? And again, there is WebAuthn request send, a register request, user identity like UPN, nonce from the identity provider, and we are using client to authenticator protocol to use our security key, our FIDO2 device. And obviously on the left side, we have this user, yes, register for login.microsoft.com. So now, let's say that spoofer created website called loginmicrosoft.com. It's quite similar to login.microsoft.com, yeah? So now, let's say that, yeah, this link was sent to the user. User would like to sign in to login.microsoft.com. There is WebAuthn request, a return, yeah, and it's login request, and there is nonce to send to the browser. What will happen there? Browser using WebAuthn API and client to authenticator protocol will make a check. Is there a record for below domain loginmicrosoft.com? No, there is not. There is only record for login.microsoft.com. So what will happen? Basically, new registration will be created. So login.microsoft.com will land on the device in the storage for this UPN for the user, and new public key and private key will be generated. Yeah. So it's super important to mention that obviously, yes, we can say that, okay, there is new registration created for this fake loginmicrosoft.com domain, but let's see what will happen then. So registration is done, and obviously what will happen, let's say that spoofer website is replying this attack to the Entra ID. So it's trying to use this nonce to signed by the user with identity provider like Entra. What will happen, obviously, as you remember, I mentioned that Entra will always return a unique new value of the nonce. But what will happen here, Entra will look into the nonce, yes, and will try to check its signature. So signature with public key and nonce value match. And as you probably imagine, it will fail, yes? Because it's not the nonce that was generated by identity provider, which is Entra ID in this case. There is no public key for such signed nonce on the identity provider side, on the Entra side. So this check will fail. So Entra will try to, return the nonce free to the spoofer's website, but it will not work. Why? Nonce free cannot be signed with the user's private key. Attacker does not have access to private key because, as you remember, I mentioned that private key is stored only on the user device, like FIDO2 security key, and nonce 2 does not match nonce free value. So that's why this is phishing resistant authentication, because even if a spoofer will create similar website, even if user will register with FIDO security key, then it means that this will be totally separated registration. So spoofer will not be able to use any credentials from the user to access login.microsoft.com. So that's why it's super important, as you can see, to explain that when we compare passwords to this solution, basically passwords are weak. And now we can see that with FIDO2 security keys, with WebAuthn, this is really phishing resistant authentication. Okay, perfect. So now it's time to talk about passkeys. So there can be some confusion basically, because some of you probably heard about FIDO2 devices, security keys, passkeys, and so on. So I would like to explain some concepts here and basically clarify on passkeys. So let's start with passkey definition. Passkey is a FIDO2 credential that can be stored on a variety of different devices, like security key, like this USB pen I showed you at the beginning of this video, computer, laptop, PC, mobile device. So many different kinds of devices. And passkeys are multi-factor. Why? Because there is a user and there is activation factor. So user will have to either use something user knows or something basically user is. So either user has to use fingerprint to unlock the credential on the security key, or user has to provide the PIN. And then there is auth factor, something user has, which is security key. And then user can access resource protected by Microsoft Entra ID and any other identity provider which supports passkeys. So that's why passkeys are multi-factor in nature. So that's very important to mention. Okay, there are two types of passkeys. Device-bound passkeys. An important thing here is that FIDO2 security keys are now called device-bound passkeys. So when you will hear FIDO security keys, FIDO2 security keys, you basically have to think about passkeys, defined by passkeys. So that's very important. So from now, every time you will hear FIDO2 security keys or security keys, you think about device-bound passkeys. So the passkey is this new naming convention. So in the future, expect to see more passkeys names rather than FIDO2 security keys. They are also referred as non-syncable passkeys. Yes, so we cannot sync the credentials that are stored on this device with the cloud, for instance. It's only about the device itself. It's required to proceed with phishing-resistant authentication. On the other side, we have sync passkeys. So multi-device or sync passkeys are credentials that can be moved and synced between devices. So that's what I mentioned. Yes, we can have multiple devices. And this means that if a user has multiple devices, they can use the built-in authenticator to validate a credential, regardless if they are using the device that was used to create the credential. So we can sync basically those passkeys using some cloud services, let's say, to simplify things. So we don't have to use the same device where passkey was generated to authenticate with another device, let's say. One very important detail here. There is no cross-ecosystem synchronization. Today, at the moment of recording this video, obviously, it can change in the future, but at the moment of recording this video, credentials created in one ecosystem like Microsoft with Windows 11 do not synchronize with any other ecosystem like Google. So please remember about it. Right now we have separate ecosystems. There is Apple, Google, Microsoft, and they basically have their own ecosystem for passkeys. One more important aspect, similarly to passwords, passkeys can be managed natively, like with Google Password Manager or Windows 11 Passkey Manager, or through third-party passkey managers, like WebAuthn. Okay, perfect. So now let's talk about passkeys with Microsoft Entra. So today, Microsoft Entra ID supports device-bound passkeys. So we can either use Windows Hello for Business or FIDO2 security keys for strong authentication, for phishing-resistant authentication. But in the future, there will be one more great option, and this was announced during the Ignite 2023. Passkeys with Microsoft Authenticator. Device-bound passkeys will be supported by Microsoft Authenticator app. Will be available on Android 14 Plus and iOS 17 Plus devices, and Microsoft Authenticator will be phishing resistant with device-bound passkey support. Which is cool, because instead of using any FIDO security keys like USB keys, we will be able to use Microsoft Authenticator to store our passkeys and to use phishing-resistant authentication method. There was also one more great announcement that in the future Microsoft Entra will support device-bound passkeys on computers and mobile devices. Okay, great. So that's about the theory, but now it's time to see the first demo. Windows 11 passkeys experience. So let's start. To easily test passkeys with Windows 11, I will use demo application available under WebAuthn.io. From there, I can register and then authenticate using passkeys. So here, I will provide my username, like this, and I will click register. Now we can see that Windows security pop-up is visible, and there is a question. Use your device to sign in to WebAuthn.io. I will click OK, and then I have to provide the PIN, because once I will provide the PIN, passkey will be generated and stored on this device. So I have to provide the PIN for my device, and we can see that passkey was successfully saved. And there is information. You can now use Windows Hello to sign in with your face, fingerprint or PIN. And here is my username and obviously the domain, so webauthn.io. I will click OK button. And there, before I will click Authenticate button, let me show you one more thing. If you click Windows icon and you will start typing passkeys, you can see that under Accounts you have this passkeys section. And from there you can see all your passkeys generated on this device. And here is my passkey for webauthn.io website. And here is my username. Perfect. So right now let's try to sign in with this account. So I will click Authenticate. Again, Windows security pop-up is visible. I have to provide the PIN I'm using on this device, and hurrah! I'm successfully authenticated and I don't have to use any passwords anymore. Okay, perfect. So now let's see the next demo. In this next demo, we will see how to sign in with device-bound passkey to the application secured by Microsoft Entra ID. So let's start. Here is my demo application. It's Blazor server application secured by Microsoft Entra ID. And in this application, when I will click login button, obviously the login page will be displayed. We are redirected to the authorization endpoint of Microsoft Entra ID. And from there, in a classic approach, I'm using username like this, and then I have to provide the password. Yes? Once I do it, then I'm asked for permissions, so I see the consent screen, I accept, and then I'm successfully authenticated, redirected back to the application with set of tokens, and I can start using this application. But obviously in this scenario I used password, and we would like to eliminate passwords. So in this case we will replace password authentication method, and we will add option to sign in with device-bound passkey. So let's see how to do it in Entra ID. Here is Microsoft Entra Admin Center, and from the left side under Protection we have to select Authentication Methods. This is the place where we can enable authentication with device-bound passkeys. So under Policies there is FIDO2 security key method. We have to select it. It's not enabled yet, so let's open it, and we have to switch to enable. And obviously once we do it, we have to click Save button. What we can do, we can either enable this option for all the users in Entra ID tenant or selected groups. And also under Configure tab, we can allow self-service setup for users. We can enforce attestation for device-bound passkeys for security keys, and we can configure some other settings here. I will leave it as it is right now under configuration, and here I will enable it for all users. And I will click Save button. So right now, FIDO2 security key method is enabled. So right now, I will have this chance to sign in to my application using a device-bound passkey instead of using the password. So let's get back to the application and let's see the experience. As you remember, I mentioned that before we can authenticate with device-bound passkey, we have to go through the registration process first. And this is exactly the same for Microsoft Entra ID. So we have to go to myaccount.microsoft.com, and there we have to authenticate first. For the demo purpose, I will use account from Alex. So we will do this registration for Alex, that is the user in our tenant. So Alex will sign in to my account, Microsoft.com. And from there, what Alex will do, Alex will register new device-bound passkey. So basically, new security key. So from the left side, Alex has to go to the security info. And from there, Alex has to select one of the sign-in methods. Default one is password, as you can see, but by clicking Add Sign-in Method, there is an option to choose another authentication method. In this case, to enable device-bound passkey authentication, we have to select security key. And then we have to click Add. And as you can see, there is important information. To set up a security key, you need to sign in with two-factor authentication. So if Alex doesn't have to Microsoft Authenticator configured, Alex will have to go through the MFA registration first before he can register new device-bound passkey, new security key. So we will click Next. And as we can see, there is this MFA procedure. Yeah. So first of all, Alex has to set up Microsoft Authenticator app. So what we will do basically, or what Alex will do, we'll click Next button, and again Next button. Alex will scan the QR code with the Microsoft Authenticator app on his phone. Alex will click Next, and then the code is displayed. So Alex has to provide it in the Authenticator app. And that's it. Authenticator is successfully configured. We can click Done button. Alex will go to Security Info. And Alex will click Add Sign-in Method. So from there, we will select Security Key again. We will click Add. And then we have this option to choose. Like, is it USB device, NFC device? We will select USB device. And we will be asked to plug the device to the USB slot in our computer. So in a second, we will be redirected to a new window to finish up this setup, hopefully. Yeah. So as we can see, again, we can see Windows Security pop-up. From there, we have to select Security Key. And as you can see, we will configure this security key for Alex account. So we will click OK. And basically, this passkey will be for login.microsoft.com for Alex account. We will click OK button. And now, what I will do, I will plug in the security key into the USB slot. And then we have to configure security pin for this device, and we have to touch it. So I will touch it right now. And as we can see, passkey was successfully saved. And now Alex can use this device-bound passkey to access login.microsoft.com. We will click OK button. Yes. And then the registration is completed. So right now, Alex has device-bound passkey as one of the authentication methods available for him. Obviously, in the future, Alex can choose to resign from using passwords at all, and he will only use device-bound passkey. And here is the security key name, so Alex passkey, let's call it like this, and let's click next button, and we are all set. Perfect. So here we can see that our security key is successfully registered. So right now, let's try to access the demo application I showed you a few minutes before. Perfect. So here is my demo application. I will click login button, and from there I will select sign in options, and then I have to select sign in with Windows Hello or security key. So then Windows security pop-up is displayed, and I'm asked whether I want to use my existing passkey from this device. But in this specific scenario, I will select use another device, and I will select security key option. And then I will click next. I'm asked to insert my security into USB port, so I will do it right now. Then I'm asked to provide the PIN for this security device, and I have to touch it. Once I do it, I'm asked to select the account. So in this case, I want to use this security key for Alex account. So I'm selecting Alex, I click OK, I'm successfully authenticated and redirected back to the application. So here is this greeting, hello Alex. Perfect. So right now, instead of using password, I used device-bound passkey. That's it for this video. I hope you found this interesting and helpful. I'm super excited about the passwordless future with passkeys. I also can't wait to use Microsoft Authenticator app with device-bound passkeys. I hope to see you in the next videos. Thank you so much for watching.